This video is about the application of differential equation. We're gonna do the problem about the mixture problem. Uh, the mixture problem will be the word problem that is gonna be about experiment that you are having a tank initially contain 20 gallon of pure water. So this will be, you have to read the question and you may have to interpret the question a little bit. So this one is going to be the first sentence of the problem. So we're gonna be able to draw a picture that you're gonna have 20 gallon of pure water. And the experiment begin with the brine containing 3 pounds of salt per gallon flow into the tank and at the rate of 2 gallons per minute. So the information that we can gather from this sentence will be you have something flow into the tank. So it's gonna look like this one that I'm gonna draw an arrow like this, and you're gonna have the concentration of the brine is 3 pounds per gallon. So it means that for each gallon of the brine, it will contain 3 pounds of salt. And you're gonna have the rate of the brine that flow into the tank 2 gallon per minute. Okay, and it's gonna go into the tank and it's gonna stir in the tank, and the well stir mixture flow out at the same rate. So it's gonna flow out at the same rate. Okay, so the rate that gonna flow out will be 2 gallon per minute, the same rate. Okay, and we like to determine how much salt in the tank at any time. Okay, so that will be our first question. The second question will be, so this one is your first question. Okay, the second question will be how much salt is present at the end of half hour. Okay, so that my second question. Okay, so this will be our situation so far, and we like to have at the long run. So how much salt is present in the long run? So this one is the third question. So we have 3 questions for this information. Okay, so we gonna answer them by using the differential equation that we have learned. Let's take a look the way to do this one. I'm gonna let AX be the amount of salt at any in the tank at any time x. Okay, so we would let AX to be the amount of salt. Okay, I use A for the amount. So it's gonna be the amount of salt. Okay, so it's gonna be the amount of salt at any time X in the tank. So from this information, pure water, the pure water will imply that A at the beginning, when you begin the experiment, is gonna turn out to be equal to 0 pound of salt. Okay, so you have no salt in the tank at the beginning, so it's gonna be 0 pound. So A0 will be equal to 0 from that information. And also, okay, so we're gonna conclude first that A0 equal to 0 because of pure water. okay? And according to this diagram, we like to know the amount of salt in the tank that gonna flow into the tank. So we know the concentration, we know the rate of the brine that gonna flow into the tank. So we be able to compute the amount of salt. Okay, so I'm gonna just say salt. So the amount of salt that gonna flow into the tank will turn out to be the product between 3 and 2. Why would that be? Because you know that it's going to be 3 pounds per gallon and the brine flow 2 gallon per minute into the tank. So the salt that gonna flow into the tank turn out to be 3 times 2 pounds per minute. So this will be just salt without water. So the amount of salt that you have is going to be 3 times 2 pounds per minute that gonna flow into the tank. Okay. So, and you're gonna have it flow out at the same rate, it's 2 gallons per minute. So here it's gonna be some salt, okay? So the amount of salt is gonna be salt in this tank equal to AX. Okay, so this will be the amount of salt that you have in the tank. So you have salt equal to AX at any time X. And if I ask you about the concentration of the brine in the tank, so if you like to compute the concentration, it's gonna turn out to be the amount of water that you have. The amount of water turn out to be 20 gallon, right? So the amount of water is 20 gallon, and you gonna have the salt equal to AX. So the concentration of the brine that you have is going to be just the basic chemistry that you have here is going to be just the amount of salt over the amount of water. So that will give you the concentration. So this one is going to be AX over 20 pound per gallon. Okay, so this is the amount of salt. This one is the amount of water, which is 20 gallon, and it's gonna turn out to give you the concentration of the brine that sit in the tank after it's gonna be flow out. Okay, so we have this one, and we'll stir, and we gonna let this brine out. So it's gonna be out at the rate of 2 gallon per minute. So you're gonna lose some salt from the brine also. So when you take the brine out, so you're gonna lose some salt, and the salt that you're gonna lose is gonna turn out to be the product between the concentration and the amount of the rate that you are flowing the brine out. So in this case, it's going to be A over 20 multiplied with 2. So it's going to be A over 10 pound per minute. Okay, so this will be just the amount of salt that's gonna flow out of the tank. Okay, and this number is equal to 6. Okay, so you're gonna have the difference between. Okay, so the setup that we're gonna be able to know is gonna be the ADX. The ADX is gonna be the change in the amount of salt. Okay, so the change in the amount of salt at any time X. Okay, so it's going to be the change in the amount of salt at any time. So this guy is going to be given by the rate of flow in, rate of salt flow in, rate of salt flow in. Don't say rate, it's going to be salt flow in. Subtract by salt flow out. Okay, so it's going to be salt flow in, subtract by salt flow out. So for this one is going to be just, you see that salt flow in is going to be 6, and subtract by salt flow out is going to be A10. Okay, so it's going to be A10 like this. Okay, so it's going to be 6 subtract by A over 10. Okay, so this one will give you the ADX. So this will give you a differential equation. Okay, so it's going to be a differential equation. The way to solve this differential equation, so you're gonna gather the term. So you have the ADX plus 110A equal to 6, and you have A0 equal to 0. So you have the ADX plus 110A equal to 6, and you have A0 equal to 0, okay? So we're gonna solve this one, and please take a look at this one is gonna be just y prime plus 110y equal to 6. So if you have differential equation of this form, it's turned out to be linear. And this guy will be your px, and this guy will be your qx respectively. Okay, so this one we're gonna take a look at this guy as a linear equation, and we're gonna solve by just using the formula. So for this one, you would just have 110, you would just have 6 for px and qx, okay? And this guy turned out to be linear. So when you have a linear equation, you would begin with mu equal to e to the integrate px dx. So for this one, it's gonna be e to the integrate 110 dx. Okay, so that will be what? That will be e to the x over 10. Okay, so that is going to be just the integration that you have, and you're gonna have a by 1 over mu integrate mu qx dx, and this guy is gonna be what? Is gonna be 1 over mu. Okay, so it's gonna be 1 over ex over 10. Okay, and you have integrate ex over 10 multiplied with 6 dx. So you use 6 here, you use 110 here. Okay, so that for the linear equation. And this one is going to be e to the negative x over 10, and you have 6, and you integrate e to the x over 10, so it's going to be e over x over 10 over 110, which is the constant, and you would just plus c, okay? And you're gonna have a by multiplying this term to this term and this term to c. So this would give you 60. Okay, how would I get 60? I have 10 up here, so it's gonna give me 60, and this guy multiplied to this guy is gonna turn out to be 0, e to the 0, so it's gonna be 1, and it's gonna be plus c e to the negative x over 10. Okay, so that is going to be our A. Okay, so we're gonna use A0 equal to 0. We have, so we have Z, okay, so in this case, it's gonna be A0 equal to 0, 60 plus C e to the negative 0. So this would lead you to C equal to negative 60. Okay, C equal to negative 60. So you have A equal to 60 minus 60 e to the negative x 10. Okay, so this is how we solve this differential equation. So this will give you the answer for the amount of salt at any time x. Okay, so this will give you the amount of salt and times x. Okay, so this one will be the pink one. Okay, so this one will be the pink one, that is number 1. Okay, let me just write down the number. The second one will be the amount of salt at the end of half hour. Okay, so for number 2, you have half hour. So you get t equal to 30. So you have a 30 will be 60 minus e, not e, 60 e to the negative 30 over 10. So it's going to be 60 minus 60 e to the negative 3 pound. Okay, and this will give you the solution for the second question. Okay, so that will give us the second question. And finally, the third question. For the third question, it's going to be in the long run. In the long run, in this case, means you have t go to infinity. Okay, so when you have in the long run, it means that you continue this experiment until t very large, and the concept for calculus for t large is turned out to be you are using the concept of the limit. So you have limit t go to infinity of at, so it's going to be limit t go to infinity of, not t, x, sorry, we use time x. So this one will be ax, and ax, x go to infinity. So you have 60 minus 60 e to the negative x10, and this guy will be 60 minus 60 e to the negative infinity. Okay, so you have infinity for this term, so it's going to be negative infinity, and negative infinity will reach 0. Okay, so this guy will be 0, and it's going to become 60. Okay, so you have 60 pounds of salt at the long run. Okay, so when you continue this experiment, and it means that you're gonna have the amount of salt equal to 60 when you left this one, or actually it's gonna be the amount that very close to 60 when you left this experiment, like for a week. Okay, so it's gonna be kind of close to 60 pounds of salt that is gonna be in the tank. Okay. The second question is kind of the same as the first, so we're going to begin by reading the question. The first sentence for this question is going to be kind of the same. It's going to tell you about the capacity of the tank. However, the difference turned out to be you have in which 3 pounds of salt, okay, already dissolved in this tank. Okay, so this one is going to be 3 pounds of salt is dissolved in the tank. Okay, so that will be the difference from the beginning. So you're gonna draw the same diagram. Okay, so you draw the same diagram. So the capacity is going to be 12 gallon. Okay, and you're gonna have brine that you have 3 pounds of salt. Okay, 3 pounds salt already sit in the tank, and you're gonna have flow in and flow down. Okay, so you have flow in and flow out of the tank. So read the question. You have brine containing 3 pounds of salt per gallon, so that will allow us to know the concentration of the brine. okay? So it's going to be 2 pounds per gallon, 2 pounds per gallon, and you have the rate of the brine will be 4 gallon per minute, okay? So that is going to be the rate of the brine. And we have the first question that we like to know how much salt in the tank at any time x, okay? I'm not going to use t, I'm going to use x for convenience. So this one, let's change to x, okay? So I'm going to change t to x. And that will be our first question. Okay, so it's going to be this one. The second question will be how much salt at the end of 1 hour. Okay, 1 hour here, we know already that it's going to be t equal to 60 minutes. And also the question asks you about how much salt in the long run. So it's going to be, again, 3 questions. Okay, and we're gonna have the amount of salt that we have thrown into the tank equal to 2 times 4 equal to 8 pounds per minute. Okay, and we're gonna same thing, you're gonna let AX be the amount of salt in the tank at any times x. Okay, and from the information, okay, at the beginning, we have 3 pounds of salt dissolved. So this will be your A0 equal to 3. Okay, so the condition turned out to be a little bit different from the previous one. And you're gonna have the water that go into this tank, okay, and it's gonna stir together with this 3 pounds, okay. So you're gonna have the concentration of the thing that's gonna flow out turn out to be AX, okay, over the capacity, which is 12 pounds per gallon. Okay, so this guy gonna flow out with this concentration because this will give you the amount of salt first, and it's gonna divide by the amount of water that you have, which turned out to be the capacity of the tank, which is 12 gallon. Okay, and we do flow out at the same rate, so it's gonna be 4 gallon per minute. Okay, so the amount of salt that gonna flow out of the tank is gonna be just A over 12 times 4 equal to A over 3, okay, pound per minute. Okay, so this will be just the salt flow out. So you have dA dx. Okay, so you have dA dx equal to the change in the amount of salt. Okay, so this guy is equal to the change in the amount of salt in the tank. So it's gonna be, okay, the amount of salt is gonna be 8 flow in. Okay, so it's gonna be flow in. Salt flow in. Let's say salt flow in. Subtract by salt flow out. Okay, and your salt flow in is 8, and the salt flow out is equal to A over 3. Okay, so this one will give you the differential equation dA dx Okay, so you put this one in terms of dA dx plus a over 3 equal to 8, or you may just write this one as 1/3 a. Okay, and you have the condition a0 equal to 3. And again, this one is linear. Okay, so this one is linear. So you're gonna just be able to solve this one by just using mu, okay, and you have a, okay, and after you have a, you use a0 equal to 3 to solve for, okay, so you use a 0 equal to 3 and you find C, okay, so and you find C, and that will give you the amount of salt in the tank, okay. So this one will give you the first, okay, so the first question, the answer for the first question. And the second question, you compute a 20, okay, so the second question, you're gonna compute a 60, okay, so that will be your second question. And the third question will be you need to compute limit x go to infinity of ax equal to, so this will be your third question. Okay, I will leave you with this guideline and ask you to finish this one first, and we gonna discuss this one again during the recitation. Okay, so this one is going to be just follow the previous example, and you see that you'll be able to compute them, and you're going to be able to answer question 1, question 2, and question 3 respectively. Okay. Okay, so that's all. It's gonna be all for this application. Okay, so I did 2 examples. So for this differential equation, we're gonna do also the review problem in the next video. Okay, and we gonna be able to like have the like review example. Okay, so you see that you're gonna have the question about the linear question, and we're gonna do this the miscellaneous problem that we also have. Is going to be mixed problem from the 6th type of differential equation that we have been studying. Okay. Okay, so that is going to be all of the material for this semester, and it's going to be all material for calculus 2. Okay, and this topic will be the last topic for discussing or for learning. Okay, that's all.